Hi guys, welcome to our last week. In this week we will see this same effects. This it's a more advanced setup that we seen previous week. We will have some custom attributes to activate different areas. We would also prepare this for render with some GI and also more advanced render. The only difference is that I prepared this setup with Redshift because it was pretty faster to generate this kind of preview. What Redshift takes 4 or 5 minutes, Mantra takes 45. So it's a matter of doing things smart so we get them faster. So well, let's get started with this lesson. The first thing I'm going to do is to save this scene into our project week 8 under Sun Activation version 1. What we are going to do is to use another way of importing our geometry. This way allows you to import also cameras if you have them inside your Alembic. This way of creating the geometry and importing the Alembic won't work with cameras, so this way you make 100% compatible, but the node structure will be different too. So let's dive into our $hip export. Yoda Buddha, I left you here the Houdini, the Alembic file. Okay, and we see that we have a huge model here, and also another kind of let's say a geometry node inside object level. If you dive inside, you'll see you have the column and the Yoda, and well, you have a lot of structure inside here, but don't worry, we won't use this. The first thing I want to do is to scale this down, so just create a null node, name it global scale, and you connect to the nodes that you want to scale. You can scale as much as nodes as you want at the same time. I use a lot this technique because when bringing Alembic from other software, or maybe your client send you an Alembic file that they work in a complete different scene scale, this way you can adjust it just to work as comfortable as you can. So next step is to create our geometry and name it Buddha setup, and we'll use the same technique as you used in the previous week. That is, let's use the merge object merge, and let's pick our Yoda Buddha. I need this one that they have has the geometry logo in here, and let's set into this object. So right now, if we hide, we'll see we have our Buddha just super comfortable to work. The same if we want to bring the other geometry. Copy paste the base, and we go to column here. Okay, sweet. What we have to do next is to create our grain source. What I will do is keep it for now low, so we have a faster previews, and later on we will create a higher resolution version. Next thing I'm going to do is to create a color, because I want them, although they are already white, black, sorry, I want to add the attribute. And what we are going to do is we are going to add a couple of spheres animated that will do a color transfer, and that color transfer will have a value of 1, so they will be white, and we will use that value to activate the particle's gravity. So we only have effects where the sphere touch the grains. The next thing we are going to do is to create a transform attribute, and let's create a sphere. Right there, let's give a bit more frequency, scale it down, and move it to the head. Okay, let's keep it this way. First, out from our geometry. So this will be the collider. Next thing that I'm going to do is to create a mountain. So this way we make sure that the inside part of where the particles are activated and deactivated, we get a nice random deformation. There are some display issues happening here, so there we've got it. We can play around with the values. You already know how to do this. And that's not bad. And the next thing I'm going to do is to add a transform node, because this will be the animation, and plug it on our transfer attribute. So next, let's add a keyframe, and let's say we want this to hit our Buddha on our frame. Let's do this. Let's make the object, because I want to show you also the subsolver that we are using here. So right now, what happens? The last thing, and the most important, is to assign a white color. And also remember, under conditions, to the distance threshold, keep it low. Okay, so let's suppose that we want to do an animation that do this stuff, and also probably gets down and start disintegrating our object in a progress way. What happens now is that our particles, once they are white, they are activated. But the problem is that when our object disappears or get out of the radius of influence, that particles will be deactivated. So this means that gravity will be activated, and once the sphere is out, they just freeze in a natural way, and this is not what we want. We just want to keep the white particles white, although the radius of influence is out of it. So what we do for that is to use a solver, that it's a sub solver, and what it does, it records the path of our object, and white particles will keep white whatever happens. So what we will have to do is to create a solver. I want these two nodes, the attribute transfer and the color attribute, control X to cut it, and I want to connect the black color into the first input and the animation into our second input. Dive inside, and now we see that we have like a purple node where it says previous frame, input 1, 2, 3 and 4. Let's paste our nodes here, and this is easy. The only thing, if we connect to our input 1, we will have the same effects that we previously had. So we have to use this purple, that is the node that does the magic. And inside our color one, let's name things correctly, we want to connect the second input. So this way, if we hit play, we will see that the object, no matter where it goes, it records this white color on our nodes. So this is exactly what we want. Not delete this channel, but I want on frame 24. And remember, as this is a solver, you have to reset simulation to get the updates. So nice. Let's add other colliders. This is simple as adding a merge node, and we don't need to copy this structure again. Just by duplicating the animation node and plugging into merge, we'll have an exact copy. So I want this rock to delete channels and to start over frame 16 properly. Go the other way. Also, let's center pivot. Remember, $CX, Y, and Z to center our pivot. And I want to add a keyframe here, and I don't know, 45. Bring it. Let's make other copy. Let's delete and take these to this side. You can rotate or also add some variations here. In that case, yes, you will need to copy this node, not necessarily the sphere, and add some offsets there. Okay, so in frame 35 to 66, we bring it inside and add other key. So right now inside solver, okay, we see this part will be also disintegrated. What I see is that probably some points in here are not being influenced, so we can fix that by adding just a bit of radius. That's it. Okay. What's next? I want to create an attribute, the name whatever you want, but I will use activate, and I want that node to be the same value as the color. So let's say attribute create, and I want to name it active, and the value will be $CR. So right now if we go to our geometry spreadsheet, will be our activate will be 0, and some values will change into 1 once that points are touched. Sweet. Let's now create our rest position. And let's create a null, a null just to get things tidy. Out setup, and let's color it black. Let's save this, and let's create our dot network. First input, not dot network, let's make things a bit faster. Let's create a pop network. Okay, so here we are. Remember to turn off the guides. Emission type is all geometry, and also remember that we want to add an expression that only meet when frame is 1. What I want to create is pop grain, pop sprites, and pop color for now. Remember just that value is the same as this guy, so let's copy parameter, paste relative reference. Let's put this guy down just a bit for now. And inside pop, let's name it pop shape. Let's go to our HFS Houdini pick, and let's pick our sphere mat. Remember that this, okay, there we are. And also inside our pop network color, sorry, let's generate a random based on ID. This is the same that we've done before, so that's why I explain it that fast. If you have any doubt, just move back to the previous week. Okay, here we have our particles. And I want to add our pop force as gravity. Negative 9.8. And right now everything should go down. Okay, nice. Two things that we have to do. Let's make our, remember our column, our base. Let's collide. make a static object from it. Okay, so there we are. If we go inside our pop, just hit L to get things organized, and let's see if our collision guide is working. With W, switch to wireframe just to have a better view of what's going on. Yes, this is enough. W again to solid view, and right now everything's disappearing. Right, I want to add our ground plane also. Okay, so as talking about behavior, remember this friction kinetic, scale kinetic, move it up. To avoid friction, and also let's add, we won't see that now, but let's add a bit of clamping. I will add a bit more of resolution. Okay, so now what do we want to do is to bring our activate attribute. If you hit a middle mouse button inside your first node, you will see that you have your activate attribute. But the problem of this is if we go out inside our pop geometry, we'll see our activate node, but if we move forward on time, this value doesn't refresh, that doesn't update. This is why it only brings us the first frame of this attribute. So what we want to do is to bring this same exact attribute to import it again, so it can be updated frame by frame. I don't know if this is a problem of Houdini, but well, the way to make it work is not that problematic. The way to do that is to create a pop wrangle, just to add just a bit of coding, not big deal. And what we will do is to import our active. The first thing we're going to do inside input, I want to import my second geometry, because I will connect it. No, let's aim to this out setup. So let's go sub, and I want to bring my out setup. And inside code, what I have to do is to create a new variable and source that attribute that it's outside in the sub level. The first thing I'm going to do is to type F, because the attribute I'm going to bring, it's a float. You say, where do you take that? It's just by in the attribute create, you see that the type is a float. So the first thing you're going to define is the type, at, and the attribute you're going to create inside this pop network. The next thing you're going to do is to create a point. 0 is for the geometry. In this case, is always will be 0. And you type the attribute that you want to import. And then the next thing you need to put is the point number, because each of these points will be a different attribute. So this way, if we hit play, we will see how some of those values will have a value of 1 or value of 0. So right now, this is easy. What I want you to do, I want to add in my pop force. I will click our use vex expression, and it's simply as typing force, that is my attribute. I want to multiply by active. So the value that currently has the force will be multiplied by the value inside active. This means if the particle is 0, gravity will be multiplied by 0. The result will be 0, no gravity. If it's 1, it will get this attribute, and gravity will be activated. Let's see what happens. It's working, not as we want, but it's working. You see how those white areas are activated, gravity is on, but the problem is that it's pushing the other particles. We don't know why. We don't know. We don't want that. How do we fix this? It's also easy. One particle pushes the other one because it has a mass. Mass right now is the default value of mass is 1. We want the areas that stay still to have a mass of 0, no movement at all, no velocity. We don't want anything on them. So the best way to get that working is to add a conditional. A conditional that says if activate is 0, mass is 0. If activate is 1, mass is 1. So let's see how we type that. The ones that use I don't know, other languages as Python or scripting in Python or Mail script is pretty similar. The ones that never done coding, I will explain step by step, so don't worry. We start by if. We open this kind of bracket or parentheses. I don't know how exactly how you say. And what I say if active attribute is equals as 0, and you open and close a statement with brackets. So if it's 0, you type mass, because we already know that attribute mass attribute is typed like that. Mass is equals to 0. If active is 0, mass is equal to 0. Close bracket and type else. And we have to add another statement. What happens if it's not equals to 0? You say mass is equals to 1. Sorry. So if active is 0, mass is 0, otherwise or else mass is equals to 1. Let's see what happens now. Okay, that's exactly what we want. The still particles will never move, although they collide with the other, and the others move free. They never are deactivated. So great, we are happy with this. Let's save our scene. Other thing that I want to add that I added to my setup is the same we've done in the previous lesson. That it's to add a point bob and attraction weight. I think it was the attribute. Let me refresh. Attraction weight, yes. So this is the same that we've already done. Let's create a turbulent noise, connect our position, our feed range and clamped to value, and our feed range. Let's try into our CD just to see what's going on. Later on we will disconnect it. No, we don't need to disconnect because we create the attribute active before changing the color, so no problem, we can change the color, but have in mind that if you do this here, the active attribute will change. So let's increase our frequency. Let's make a bit smaller. Okay, so remember the black dots will be like a free, no attached particles, and the other will be just larger pieces. Okay, so what we do next is to do a bind export, where our attraction weight attribute will be created and written with these values. Let's see if that's working. So attraction weight, have active, everything's good. Just to see a better result, let's increase not that much, probably 0.4. It seems that some particles are going inside, but don't worry, this is because we are not having enough constraint iterations. And also remember to set this substep up. Okay, now this will take a while, so let's go back. And let's leave only 100 frames. Okay, probably we are having too much. It's not very high resolution, but probably we are having too much. Attraction weight. I will lower it down just a bit. And a bit more resolution, and let's see what we get. Okay, let me do the preview and we come back and see what happens in a faster. Okay, now we can see a bit what's going on. Probably it's a bit wet sand, but I love the way it started, like activating. I like the big pieces. Probably it's a bit too much weight here in the clamping, but well, just play around and get your version. A thing that you have to have in mind for the preview that you've seen, I've used it point separation of 0.15, simulation on my i7 with, let's see how many cores do we have. 6 cores. It's not a super great processor, but this takes about 3 to 4 hours. The new generation process can take 1.5 hours or 2 hours. But well, the idea is to leave the calculation, just make it happen, do the cache. But well, this is the resolution that you've seen on my preview. For now, let's keep this guy down. So right now we have our setup ready in terms of animation and effects. Everything set up. Now feel free to do whatever you want with this. One last thing is let's set up everything to do the cache by hitting dop in out. What I will do is bring my cache, but in case you want to, you will do your own cache, map into dop network, and inside dop node you need to get your let me search for the pop setup, and you need to use this pop object is the dop node. That is this guy, the one that you need to cache. Once you are happy with that, save to file, set your frame rate, do your cache. I'll bring my own cache. Let's see where I've left it. Is this one 73 gigabytes for 150 frames. Remember to load from disk. And there we have our Buddha with 3.5 million more or less particles. So next thing, let's prepare this for render, and let's put the flag here and see what we get just by hitting render. Okay, as the cache I made had the color connected to the attraction weight, it appears this way. It's like a giraffe. But what we are going to do is inside grains to abrase. Select the abrase sand, hit enter, and it's abrasing it. This is when things get a bit slow and you need to have a lot of patience. Okay. Points per points, we don't know, we don't want 10, at least for this. At this instance, maybe for the final render it will be good, but right now let's set it to 2. And let's see inside render view if we get a nice random point color. Awesome. What I hate is the ramp that comes by default. Okay, let's make our own. Dot color is not bad. I don't want this, just hit delete. I don't want that either. I'll probably get this a bit dark, this lighter. And that should work a bit better. Okay. Things to have in mind. Right now we have the display visibility here under our color. This means that all this process of multiplying particles will happen every time you want to move from frame to frame or to make any update. If you middle click here, we have now 7 million particles. There's a way to avoid that. Let's say I only want to have as I don't want to display this now, but I want to render it. Just by clicking Control and left click button, you see that only a purple flag will be activated on your node. This means that render will be done here by displayed on viewport will be the same as you are doing here. So right now I'm displaying my 3 million particles, but if I want to render, I will render my 7 million particles. This is extremely useful when dealing with high resolution stuff. Also, what you can do in terms of earning a bit of time, you can inside load from file set a bounding box. So right now your scene is super fast, just to keep on setuping stuff, but this won't happen correctly if this bounding box option is on. So you have to play around with that. Other things, and to get things smart, to make the lights setup, I don't want to do them for now with points. I can use the geometry. That will be faster to set up the lighting, the bounce, to get everything rendered, and once you are glad with that, just yes, you switch your particles. Sometimes it's just a matter of being smart to earn time, because if not, things will take ages. What I want to do is to bring my other geometry, that it's this one, but I want to display it in a brand new geometry node. So I copy and paste here and display my flag. Okay. Let's create also a camera and put it more or less where we want that. Yes, one thing that I didn't do is to change the display flag, the render flag, sorry. It's right here now. So by hitting Control, we have it here now. So now things are faster. Okay, let's start creating our geometry, our environment, and then our light setup. Let's create our BG. I want this to be a box. Just like that. Hit W to have a wire. And well, that's it. That's more or less what we want. The next thing I'm going to do, I want to delete the front cap. And I want this to be like I get a sun ray just this way. So what we are going to do is to add a subdivide, but I don't want to get rounded areas, so at algorithm, let's hit our last option. Okay, and what I want to do is to delete these guys. So I want the light to come right here. So nice, this is our environment. I like this. Just for now, it's good. Next thing I'm going to do is create our lighting. Let's create our distant light and put it just where we want that. Okay, just to place lighting in a comfortable way, because if I want to render a preview, I have to come here, hit play. Well, I moved the camera, I put it again where it should be. I make the environment a bit bigger. Okay, so in case I want to set up the lights and rotate and scale them, I just have to come here, and if I want to rotate it, come here again, rotate and see how it refreshes. There's a way to make our float panels to do things more comfortable. If you have a couple of monitors, it will be super comfortable. And this way, by hitting window, create new float panel, you can create the panel and put it wherever you want. Just by right mouse click here, you can select the type of panel you want to create. You can create a parameter, network. What it matters out as now is our render view. So right now let's select the same things that we've been. If we hit G, we get our area. So now we can make this smaller, take the lock on our camera, and go and play around with our lights. That's what we wanted. Okay, this is the nice thing about Mantra. I really love the bounce and the way it works. It's so soft and nice. The only problem is the time that it takes to do all this, but well, every render engine has its own pros and cons. So this is our sunlight, and I want to create now a GI, a global illumination, just to get some bounces here. So let's click our GI light. Okay, let's turn off the progress. We can change the intensity. But well, we see right now that we have a lot of noise on our scene. The things that you have to have in mind are the photons count. The more photons you have, these are like the rays emitted by the GI. We can, for this, keep it down so we don't have any change. That will be a bit faster. And also inside our indirect diffuse, we have the sampling quality. We can increase this a bit to have a smoother result, but this won't be fixed from here. The way to fix this is from our ROP node. So let's go and see what's going on. This is the node that has been automatically created when hitting render for the first time. So the important thing in here, just to optimize a bit inside rendering, the important guys you want to play with are the min max ray samples and the pixel samples. Remember that every change you make here might increase your render time, but also will make your render smoother. Also, the difference between this and this value should be not more than 10 or 15 units. This means that this is one that cannot be 20. It's better to keep this going together. If we increase the rays, we'll see how things become more and more soft. But also render time increase a bit. And also, just for final render, make sure you increase your pixel sample to 5, 6 will be. You will see how every time you change value, your render gets more and more smooth. This is the difference that I told you between Mantra and Redshift when dealing on Facebook group. What you want me to use for this lesson. This process in Redshift is very clean and a nice smooth GI with a render that won't take more than 4 or 5 minutes. And yeah, Mantra will take a bit more, and just as an estimate is 20 minutes, and we are having a 720 HD resolution. So yeah, these are the things you have to have in mind. For production, Redshift it's very nice to have a very fast render engine. Not in big studios where you have a render farms, but if you work as remote freelancer and the client makes changes and he wants from 1 hour to the other one, so you cannot wait 40 minutes a frame for a 100 frames sequence, because scenes will be very bad for you. Okay, now we have something that is working, and GI is working pretty clean. So what's next? Let's activate our particles and see what's going on. We can add 3 points, and let's put only the flag here, the render flag. So it creates a geometry. It says up there, created the geometry. This is taking ages because probably the render setup is a bit higher. Let's for now do this because it will drive us crazy, at least to see what's going on. We can also use the deprogressive. Well, we see that we have dark areas. We probably want to add a bit more of bounce and also a bit more of our main light. Let's see what happens on his head. Yeah, although we have some bounces here, we want probably to increase that. Also the main light, just with this sand setup, we are not getting what we want, so let's increase our light a bit, sunlight. Okay, something's better happening there. Let's see it face. Also the render, the preview that I prepared for you, that was well, with Redshift, but I have added a color correct on After Effects later on. So that's a bit better. Probably the bounce is a bit high now. And let's give the resolution that, well, now it's a matter of playing, doing your own version. Please don't copy this same class. It's just, I always repeat you the same. This will be your portfolio, what people will see to hire you. And if they start looking on the internet and they see 10 or 15 or 20 people doing the same exercise, that sounds strange. So it's better that you use your imagination. On internet there are plenty of things, models to use, videos on Google, Vimeo, YouTube. Just dive inside, take a look, experiment yourself, do other versions. I don't know, just use your head, because it's not a matter of using the tool, it's not to be creative and to have a nice art and a nice artistic and nice technical result. I will pause the video right now and wait, I don't know, I think that half an hour at least, to have some progress on this. And we finished the video, so let's see our result and I'll come back later. Okay, here we are again. I will leave the render till here, half an hour elapsed it here, and it's an estimate about another hour. So yes, let's leave it as it is, half an hour, sorry. It should take about an hour, probably less, because we don't have grains right here. So that's it. Now you see a very nice render with some sun bounce here, some warm, other some light. Here we have different colors. You have a pretty nice render here. I really like the result. But well, later on, remember to add a couple of play around in comp. You can contrast. I don't know. Do your own version. You already have the tools, so okay, that's it for now. This way we close our first module. So let's see next module 2, rigid bodies. After you finish your task, please submit it to our Facebook page. Thanks a lot. Bye.